And it looks like we'll go ahead and get started. Welcome everybody out to my talk. I'm going to be speaking about AI for software engineers using the Golearn repository, just by way of introduction. I am a data engineer at a company in Lehi, Utah called Weave. We are a small business communication and toolkit platform. I also am an organizer of several meetups and a Go conference with the Forge Foundation, and I'm a proud mother of 2 dogs. My info's right here if you want to connect later. The slides are available online. And these are my current dogs. The little black one's a puppy. She's a lot bigger now, 5 months old. And then the one on the top is 2 years old. So those are my babies. Just by way of introduction, to get your guys ready, a lot of people come into these talks without a good set of expectations. I kind of want to set those expectations right now. This talk is very specific to using AI as part of the software engineering toolkit. And so I'm not going to be talking about why we want to be using machine learning in Go specifically. I'm not going to talk about Go versus Python. I'm not going to go into all of the possible frameworks for machine learning in Go. There are a ton. They have different uses for different cases, and you should go explore those yourself. I'm not going to be diving deep into any math, a bunch of definitions you kind of have to go with me on and look them up later, and I'm not going to talk about neural networks at all. Sorry, those are way fun, but that's not what I'm talking about. So just by way of introduction, what is machine learning? Conceptually, it's really easy just to think of machine learning as a way to solve a problem. I like to think of it as a switch statement, like more than just a switch statement, a very overcomplicated switch statement. For example, say you want to determine a cat versus a dog. So you take a picture of a cat and you're going to put it in your switch statement. So first case, we know that cats have pointy ears. So case 1 has pointy ears, default not cat. You go there and you're going through it and then you notice, oh, Yorkies have pointy ears. So now you have pointy ears and long claws. And then you run into, a dog whose claws haven't been cut. So then you have to do pointy ears, certain kind of nose, shorter snout, and you start adding all of these cases, and then you end up with, 200-300 different kinds of cases for what defines a cat versus what's a dog. And that's all determined by the data when you're training the model. So it's really just an overly complicated switch statement that is defined by training data instead of by the typing fingers of a software engineer. There are a couple types of problems that tend to be really suited for machine learning. First one is classification. Everybody knows about the benefits of classifiers because they have been in our emails for years and years and years. As your spam classifiers, right? We get a whole lot less more spam than we used to a long time ago, and that's just your basic ML classifier. Another one is pattern recognition. Machine learning models get really, really good at recognizing patterns and trends, and they can start to predict them and utilize them. A specific type of model called a GANs, generated adversarial network, can use these kinds of patterns to predict and generate images. So if you go to thisisnotaperson.com, you will see an image just like the one I have here. It's a fake person. You look at it, it looks like a real person, but it's completely generated by the pattern algorithm of your GANs generator. And another one that's super common is predictions and in forecasting, such as forecasting weather, forecasting stock trends, forecasting insurance prices. Anybody that's in stock market or the financial system has tons of people working on models to try and best predict how to best invest and manage their money. So when you want to start solving these kinds of problems with machine learning, the next thing you're going to run into is the plethora of tools that are out there for you to use. There are tons of tools, and there's not really like a good way to go about choosing them a lot of the time, because there's just a tons for different things. For neural networks, you have PyTorch, you have TensorFlow, you have AutoML and H2O, you have basic machine learning and scikit-learn, you have notebooks, JupyterHub. You want to go into the Go side, you have a GOML is a NLP one, you have Gorgonia for deep learning, you have GoOnix, which is for saving and encrypting your models into a language agnostic form, so it can be uploaded by different kinds of things. You have pre-coded models. You have all kinds of tools and platforms and things you can pick from, and there's just so many to learn. It gets really overwhelming really quickly. So I'm just going to focus on one tool that I'm personally very familiar with. When you start playing with it, you're going to find that this tool might not be the best for you, but I really like Golearn. I have made some contributions to it. It's basically a ML platform written in Go, with some C and C++ buried into the back end. A lot of the models are written in C itself, or C++, but everything you interact with is a Go interface. And it's used for all of your basic classification problems. So that's what I'm going to be using today. Nothing too complicated. And like I said, one of the many, many, many tools you can use. Let's go ahead and introduce some data that I want to be using today. So I'm sure you're all familiar with the FIFA World Cup that took place a couple years ago in Moscow. At the time, there was a ton of Twitter action going around with the hashtag FIFA World Cup, and a really nice person went and downloaded all that Twitter data and curated it for me. And so that's the data set I'm going to be using now, all about the Russian World Cup. And here is just a quick little preview of the types of data we have. As you can see, we have just a couple of the things, columns. It's a table. So we've got columns, and we've got about, 5 million rows? 500,000 rows? Tons of rows. So about 500,000 tweets and 12 or so columns. And we have things in there like, we have tweets, we have the number of times it was retweeted, we have the number of likes, we have hashtags, we have times users were tagged, we have the name of the person that created the tweet, the number of followers that person had, and so on. So it's a good amount of data to pick through and sort and kind of clean up. So I decided, well, I have names that are already labeled, right? I have a user mention, which is a user handle, and then I have a name string. So I'm going to go ahead and take those out and put those as labeled as name, and then all of the other words that are in the tweet I'm going to label as not a name. So we can build a classifier to figure out what is a name and what is not a name based on this text data. So we go ahead and we pull that out, and we see that we have about 700,000 unique words total from everything. And I have it labeled as is a name or is not a name. The top 10 here are all names because it hasn't been randomized yet. So if you go down to the 720 something, it's probably false. But right now you're going to have basically all of your trues at the top and a lot of your falses later. And just something really interesting is you can do just a basic statistical analysis on it. And you can see that on average, names, certain words occur about 9 times, and that there's one word that is hit over 100,000 times. Some words occur once, and then max is about 2. So it's very, very heavily weighted towards the low end of the spectrum with a really, really high point. Interesting statistics that can help you kind of see. We're not going to have a whole lot of names in there, a lot of individual words. So, here is a bit of code that shows you how we bring in our file. Really kind of simple. We just take a CSV file and we parse it into a data set of words. Then we're going to take that and we're going to split it into 2 kinds of data sets. We're going to have a testing data set and a training data set. The training data set is used to define those cases in our model, right? They're used to define what we're going to use to differentiate between name and not a name. And then the test data set is what we're going to use to validate it. Both of them are labeled as name and not name. It's just one is going to be used to define our model and the other one's going to be used to validate it. And just a side note, this split into train test instances does have a randomize on the back end. So it's not top heavy as true or false. It's randomized in there, which helps give you the best results. So real quick, I want to just do a little sidestep into a really similar use case for machine learning. It's called the linear regression. Everybody who took high school algebra or basic algebra has done this before. You're given a plot with a bunch of points on it, and your teacher tells you to draw a line right down the middle of it, called your line of best fit in English or in America. And that's all linear regression is doing, is it's drawing a line that divides your data into 2 points. Really easy to do and set up. Right here we have an example, picking this example I actually stole from Daniel Whiteneck's Intro to Go book, Machine Learning in Go. It's a great book. But it's a little bit of TV advertising data, but it uses Golearn just the same. It does the 7/30 split between the training and testing. You pick a linear regression model, go back. You train it on your data, and then you do a predict on it. And that prediction can be used to draw your best fit line, which looks kind of like that. It predicts, this half is going to be TV data versus this half, which might be newspaper data. Really simple and really good for splitting between 2 cases. For our example, I went something that's a little bit more complicated called a decision tree. So decision tree uses different nodes or classifiers to help answer or determine the types of something. So, for example, if we were going to go back to the classify a cat problem, say we were going to classify a cat from all of our animals. And we start over here, so we take a picture and it says pointy ears or not pointy ears. So we say not pointy ears goes over here, pointy ears comes over here. So we're sitting over here at pointy ears, and then we realize that we get a picture of a bear, which kind of has pointy ears. So then we say, okay, long nose, not long nose. And so we say pointy ears and a long nose. Well, some dogs have pointy ears and a long nose. So then we're going to have to go with something like long claws and not long claws. So you basically start refining it on different features all the way down to you get to your specific types of classifiers. Just a simple logic switch is kind of how you can think of that. So to define the decision tree in Golearn, I just picked this one. It's a new ID3 decision tree, and this is just a random seed. So I'm doing a 0.6 as my randomization seed. It's basically any float can be used as that. I just went with the default from their example and did 0.6. And I go ahead and I fit it with the train data. And then we can run predictions on it against the test data. right? So we're going to define our model with the trained data, and then we can validate it or determine how accurate it is with our labeled test data. And once we've done that, we're going to go ahead and print that out into what's called a confusion matrix. Confusion matrices are confusing by nature because they're just really statistical and not as straightforward as you would expect them to be. So I'm going to go ahead and show you the printout from these lines right here. So we have, from our tree, we have a true class and a false class. We have true positives, and false negatives. So I stole this little chart from Wikipedia to kind of define what each of those are. A true positive would be when our model thought it was a name and that data was also labeled as a name. A false positive would be when our model thought it was a name, but it was not labeled as a name. A false negative would be when our model thought it wasn't a name, but it was labeled as a name. And then our true negatives would be when our model thought it wasn't a name, and indeed it wasn't labeled as a name. So let's see what it kind of says here. So the number of times that our model said it was a name and it was an actual name was about 225,000 times, which is about kind of a quarter. That's not bad. It's not bad. Our false positives were very low. So we did tend towards true over false on our, this is a false on the true. And then here, we thought, we said it was true when it wasn't about half as many times as we said it was true when it was. So that's kind of meh when you look at it. So right here, we take a precision and a recall, and those are basically kind of an average or a scale of what the raw numbers are. So precision is going to take a preference over having a false positive result, and a recall is going to take preference of the false negative result. So for an example, when you would want to favor false positive, we're going to take the COVID-19 tests as an example of a time when you'd want to favor a false positive. So for example, if you went and got tested to see if you had coronavirus or were symptomatic for COVID-19, you would rather have that tend to a false positive. So you said it was positive. So the test said you did have the virus when you actually didn't, so that a secondary test could prove it false, right? You would rather have you want a secondary test to say no than you walk away, actually be sick and go and infect other people. The same thing is very common with cancer tests. A time when you would want to tend towards false negatives might be on this test classifier, for example, when we would rather have fewer words selected as a name than words that actually aren't names, right? We would rather have less total things labeled as a name, and then we could go back and validate that later manually. A lot of text classifiers, in my experience, tend to want a higher recall score over a higher precision score. So what does that mean? What does a recall of 0.66 and 0.88 mean in the real world? It means we probably wouldn't want to deploy this to production because the people in charge of your teams or the executives would not want to put a whole lot of confidence in that. You might want to tend towards something a little bit close to a 0.85 to have a little bit more confidence. It again depends on your model. If it's a data set that's very untested and you kind of just want to get better data, you might be okay with a 0.66, but generally speaking, people want things to be as accurate as possible. This is just kind of meh. So, do you feel like a machine learning expert yet? Or do you kind of feel like this? Usually, after a quick read through, we kind of just really have no clue what's going on. And that's okay. Machine learning is hard. Nobody gets it on their first try or their 17th try. It's just fine. You just have to go dive in and start learning. All of my examples are available on my fork of the Golearn library on my GitHub. If you want to learn more, Arden Labs has a good training on theirs that was written by Daniel Whiteneck. You could also go to Daniel Whiteneck's GitHub. The link is below the Arden Labs one. He did a workshop for GopherCon a couple years ago that I helped him with. And all of that material is online. And just for a general machine learning kind of course, that I recommend Google's machine learning crash course. That one is super awesome, very comprehensive, goes into everything and touches base on all of it. So it can give you a really broad overview. If you have any additional questions for me, feel free to reach out to me on the Gopher Slack or on Twitter. And that is all I've got for you today. Thank you.
We are live. We had some questions. I guess many of them can be summed up. Why Golearn? Why not use, something that everyone uses, the most popular frameworks for machine learning?
Yeah. I guess there's the benefits for choosing a Go framework or Golearn is to keep everything in Go, right? If you have if your software stack is better supported because you have more Go devs, or you don't want to have to support multiple languages or deploy an entirely separate Python app, then it's really worth your time to look into using and implementing one of the many Go machine learning frameworks. And there's a lot of them. I just have the most experience in Golearn.
Okay. I see you answered all other questions. Does Golearn support any form of GPU optimization, or it's like completely on CPU, like the no option at all?
Completely CPU. As it doesn't really go into many deep learning models, there's no need for CPU parallelization. As much as I'm aware, the only all-Go deep learning is Gorgonia, and they would have that included in theirs.
Okay. Yeah. How do you use Golearn? And basically, I guess the question is outside of work, for stuff, for hobby.
I've used it a lot for talk demos. That's my most of my hobby work ends up going into talks, which is actually kind of funny. You do examples and then you display them. So yeah, I've done a little bit of NLP, and I've actually, a lot of the stuff I've been doing with Golearn is trying to dig into their models and migrate a little bit of their C stuff into Go, see if that can be done. So I'm trying to work on the actual package and less on the implementation of it. So I'm probably not as helpful as I could be with that question.
Okay. Yeah, and then people love your dogs.
I love my dogs too. They're just very noisy.
Yeah, we can see that you try to calm them right now. Yeah. Have you optimized Golearn model for name classification somehow?
So the model that I demoed is definitely not optimized. It's very rough. And the reason for that being is I'm using the raw bytes as encoded in Unicode, as opposed to having them in a numeric encoding, which would ideally be the case. So if you want to do a word classifier or a name classifier, first step would be doing a word encoding or a word vectorization. There's this good library called GOML. It's GoML, but it's pronounced GOML. I'll add a link. There it is. That has a really good demo of how to vectorize your text data. And that would be the next step. Yes, I do all of our data cleaning in Go at work.
Okay,
it's super fun.
Yeah. Let me just read the question.
Okay, sorry.
On the recording. Yeah.
I'm getting distracted.
Docs. Don't let you continue with the talk. Yeah. Do you do data cleaning with Go? Yeah.
Yes, that we do. So at work, my work, we are 100% Go. So all of our data ingress and data consumption and data storage we do in Go. And so we do all of our data cleaning in Go. It's super fun.
Okay.
Parsing JSON in Go.
Okay. So yeah, I mean, you did it mostly to have a single language, right? So like compared to maybe it may be somewhat like maybe shorter, maybe somewhat nice in other languages, but yeah, there's definitely some benefits in having a single language in the whole stack.
Mm-hmm.
Yeah. Okay, so looks like we don't have any more questions. So another question. Do you use a Go library to recode data?
I don't quite know what you mean by recode.
Yeah. Same here. Nigel, can you maybe try to explain? Maybe record. Yeah, maybe. We don't know.
Well,
record convert many categories to a few.
Oh, so no, I do not have a library to recommend for that. I've done most of the stuff I've done has been manual implementation for how I basically want the format to be done long term. You will find libraries for doing that in Python because it's not typed. But once you get into a typed language, it gets a little bit harder, and you kind of end up doing a lot of manual implementation, which is what we end up doing.
Mm-hmm. Yeah, what is the point from which it would be better to switch from Golearn to some other framework?
It depends on your use case. It always depends on your use case. I think whenever you're testing a machine learning model, it's always good to implement it if you have the resources, right, to implement it in a couple of different frameworks and see which one gives you your best accuracy, your best precision and recall, and how hard those would be to implement in your stack in production, right? There's a give and take, but you should always experiment and look around, see which models work best, see which frameworks work best. And as long as you're using the same data, it shouldn't be that hard to be able to compare. And then from that point, you would be able to decide where to go, right? It depends on what's most important in your production implementation.
Okay, let's see if I have more questions. What is the best machine learning framework now?
It depends on your use case. I'm partial to all Go frameworks. If you want to go into deep learning, I personally really like PyTorch. I think it's the easiest to implement for your deep learning models, your convolutional neural networks, or your anyway, any deep learning. I prefer PyTorch. If it is basic machine learning, I tend to do scikit-learn if I'm in Python, or Golearn if I'm in Go. And that's just from comfort and familiarity.
Okay. Have you tried dvc.org? I don't know what's that.
I have not.
Okay. And then people are joking that MyFront is the best framework for machine learning. I guess it should be cryptorant, because it's more secure. Okay. Okay. Yeah. Okay. Thank you. And yeah, we will not take more questions. Thank you. Then we will see you in 12 minutes with our last talk. Okay. Thank you, Miriah, again.
You're welcome.